Alright, so in this video, I'll be showing you how to factor quadratic equations in the basic form ax squared plus bx plus c is equal to 0. So here I have two basic examples of factoring the quadratic equation in its basic form. Just set those equal to 0. So for our first example, x squared subtract 7x subtract 18 is equal to 0. So we can also look at this as our basic formula, which we saw from the first sheet. Ax squared plus bx plus c is equal to 0, where a is equal to 1, which is the coefficient of x squared. B is equal to negative 7, which is the coefficient of x. And c is equal to negative 18, which is our constant. So in order to factor this, we have to find two terms that multiply to negative 18 and add to negative 7. So let's start by writing out the basic factors of negative 18. So basically two numbers that multiply to negative 18. So we have negative 1 and 18, 1 and negative 18, just the inverse, negative 2 and 9, and 2 and negative 9. So if we go through our factors, let's just go through and see which ones add up to negative 7. So negative 1 plus 18 is 17. That doesn't add up to negative 7. 1 plus negative 18 is negative 17. Negative 2 plus 9 is equal to 7. It's close, but not exactly negative 7. And 2 plus negative 9 is equal to negative 7. So we know that these are all wrong, and these are the factors we will use to factor this general equation. So we can put these factors into the form x plus our first factor and x plus our second factor is equal to 0. So if we put 2 in, x plus 2 times and our second term, which is x subtract 9, are both equal to 0. So in order for this equation to equal 0, one of these factors, or one of these brackets, has to equal 0, because you know that one of these zeros times the bracket will also equal 0. So we set both parts of our equation equal to 0. So if we bring this down, x plus 2 equals 0. Solving for x, we can see that x is equal to negative 2. So all we did there was subtract negative 2 from both sides of the equation. That'll cancel out the 2 and bring a negative 2 to the right side of the equation. We can do the same thing for our second bracket. X subtract 9 is equal to 0. So we know that x is equal to 9. So we know that the values of x for negative 2 and 9 will make this equation equal 0. Alright, now let's have a look at example number 2. This is a bit more of a complicated example since we're dealing with higher numbers. If we use our basic principle from before, we have to find two terms that multiply to 63 and add to negative 16. If we do what we did before, we'll find that our two numbers are actually negative 7 and negative 9. So we can write this general equation as x subtract 7 times x subtract 9 is equal to 0. Okay, so now if we solve for each part of our bracket, x subtract 7 equals 0, x equals 7, and x subtract 9 equals 0, x equals 9. Okay, so let's have a look at some more difficult examples. In these examples, you may take notice that there are actually values of a this time. So if we write out our general formula for factoring quadratic equations, ax squared plus bx plus c is equal to 0. So our value for a is 24, value for b is negative 22, and our value for c is negative 35. So when we have values of a, instead of just finding two numbers that multiply to our c value and add to our b value, now we have to find two numbers that multiply to our c and a value and add to our b value. So I'll show you what that looks like. So we have two numbers that multiply to 24 times negative 35, which is equal to 840, and add to negative 22. If we do what we did in our first example, we'll find that these two numbers are actually negative 42 and 20. Now, instead of just putting these numbers into brackets like we did in the first example, we're actually just going to make two different expressions for our middle term using these two terms. And I'll show you what that means. So 24x squared, subtract 42x, plus 20x, subtract 35 is equal to 0. I'll write that a bit neater. 24x squared, subtract 42x, plus 20x, subtract 35 is equal to 0. So what we did is we made a new middle term using the two expressions we got from here. Now take notice that if you were to add these two middle terms, you would get our middle term from our very first equation, which is negative 22x. Now what we're going to do for the next step is turn this equation into two separate parts using brackets, and we're going to factor the two parts of this equation. So for our first part, we can factor out a 5, which is just 4x subtract 7. And for our second part, we can actually factor out a 6x. So 6x, it turns this part of the equation into 4x subtract 7. Now notice that these two parts of the equation are the exact same, so we can combine them. And these two parts of the equation can make a new second term. So 6x plus 5 times 4x subtract 7 is equal to 0. Now if we want to solve which parts of the term equal 0, or which values of x equal 0, we can once again, like in our first examples, set these brackets equal to 0. So 6x plus 5 equals 0, and we'll find that x equals negative 5 over 6. If we look at our second part of the equation, 4x subtract 7 equals 0. So x is equal to 7 over 4. And if we are to sub these values back into our original equation, we'll find that the equation will equal 0. Now let's have a look at example number 4. So in example number 4, what we can first observe is that there's a greatest common factor in this equation, which is 3x. So if we take out 3x, our equation becomes 6x squared plus x subtract 2. Now it's just a matter of doing what we did in example number 3. We find two factors that multiply to negative 12 and add to 1. We can observe from our first example that these numbers would be 4 and negative 3. So with these two terms, we make a new middle term. So 3x, 6x squared plus 4x, subtract 3x, subtract 2. And we factor both parts of the equation. So 3x turns into 6x squared plus 4x plus negative 3x subtract 2. If we factor out our greatest common factor in both parts of this equation, we find that 3x turns this into 2x times 3x plus 2. And we can factor out a negative 1 to make this match this part of the equation. So negative 1, positive 3x plus 2. So if we group these factors, we can find that 3x times 2x subtract 1 times 3x plus 2 is equal to 0. Like the first part of our first equation. So to solve for the values that equal 0, we just set x equal to 0. So 3x equals 0 is the first part of the equation. So we can see that x is equal to 0 here. We set this equal to 0, 2x subtract 1 equals 0. So x is equal to 1/2. And for the last part of equation, 3x plus 2 equals 0. We solve for x, so x equals -2/3. Okay, so now I have some practice problems that you guys can do at home, and I'll put the answers to these problems in the description below.